Hello everyone. In our today's module, we are going to be learning design patterns. So when you talk about design, let me give you some quick brush up about design, okay? So this designing is basically of two parts. One is your design principles and the other one is your design patterns. Now, if you look at it, so this design principle, that is actually your theory and there is no concrete example of the same. And if you talk about your design pattern, so this is where we go ahead and perform our major implementation. So when you talk about design principle, that is where we actually learn what we should be doing. On the other side, if you talk about design patterns, so that is where we see how we should be doing that. So in many of the interviews, you must have encountered a lot of interviews related to the interface, abstract class, delegates, and other features related to your object-oriented programming, along with the design-related questions, design pattern-related questions. So these design-related solutions are evolving from the features of your object-oriented programming. So a lot of people actually feel that what design patterns are. So a lot of people actually feel that this is code. I repeat, this is not at all a code. These are the design level solutions from the problems which we engineers are facing. I have also said it previously as well. Here we are not introducing anything new. We are not doing anything new. It's just whatever existing we are having. Here we are following certain guidelines that how we can use them in order to achieve our goal. Okay. So these, if you are going to be using these design patterns, using all of that, whatever the design you are going to be achieving for your solution, so that is going to be a that is going to have a good readability. And these design patterns, these are basically created and used by your object oriented programming languages such as Java, C Sharp and all. So these design patterns are going to be providing you the solutions for the problems which we encounter in our day-to-day life. So these are actually targeted at solving the problems of your object generation and integration. Now I'll just give you one example here. So when I was giving my interview, when I had some 2 years of experience, so at that particular time, what happened? They asked me that, okay, you create a class, and on the top of that they said, okay, now you go ahead and implement some design pattern on the top of it. So just with 2 years of experience and zero knowledge about system design, I could not able to answer it. But later on I understood, okay, how we can actually improve it properly. Okay, now we have different types of design patterns. Now how these design patterns are actually coming into the picture, how we are actually deciding that how it should be there. So if you talk about any object, so for that object we actually if you talk about any object from the object oriented programming, the center part is always the object. And with any object in any application, we can do three things. Either we can go ahead and create the object, correct? Otherwise, we can see how the behavior of the object is going to do. And lastly, with this object, we are also going to be seeing how we can structure it out. So these are the broadly three things which we can do out of our object. So based upon this, you have seen based upon this, we have a different design related design patterns which we are going to be learning here. So broadly, we have 26 design patterns, which gang of four is there who has introduced these design patterns, and category wise they have divided it into three parts. The first one is your creational design pattern, the second one is your structural design pattern, the third one is behavioral design pattern. When you talk about creational, so here we are going to be seeing how your classes are going to get instantiated. So these can either be your class creation related patterns or the object creational patterns. When you talk about creational patterns, so they are going to be giving your program more flexibility so that you can go ahead and decide which pattern you are going to be needing for your given case. The second one which we are going to be having is going to be structural design pattern. So these structural design patterns are designed in order to, like, how your class is going to get structured, how you're going to be composing your class. This design pattern is going to be focusing upon decoupling interfaces, and here we are also going to be providing the implementation of the classes and its object. What is the main goal of the structural design pattern? So the main goal is to increase the functionality of these classes without changing much of its composition. And similarly, when we talk about behavioral design patterns, so here we are going to be seeing how one class is communicating with the another, how one class is behaving with the class and the other objects. So basically, this is what we are going to be having. Now, inside your creational design pattern, the most commonly asked design pattern is the Singleton design pattern. Now, if you talk about either of the company, generally, like, people will be asking a straightforward question like, tell me what a Singleton design pattern is. Or they will be saying, okay, this is your given class, convert it into a Singleton design pattern. Or they can just ask you questions like how you are actually going to be determining if we can use Singleton there or not. So broadly, I have told you the three types of questions which can be asked out of this design pattern. So let's just take a deep dive into a Singleton design pattern and try to get answer for all of these questions. Now we are going to be learning about Singleton design pattern. If you will see this word Singleton, what you can understand from here, single. So this design pattern says, I believe in staying single, but even after staying single, it will have dominant role in the society. Singleton design pattern is majorly used when any one instance or object for a given class is required. So, like, any application, if you look in the industry, if you go by the number, like, just say, like, if you are having any of the application, and that application is having some number of applications, class 1, class 2, and, like, up to class 100. So these are the, like, different classes. If you will see, we have a lot of classes available here, right? And for any of the effective work, the flow can move through the different classes, because that is how it is designated, like the flow will go from one class to the another and so on. Now, how your code is executing, whether everything was in the place or not, how you can figure out, that is by logging in the details. And that's what all the things are happening in each of the classes. So what you can do, you can just log it. I'll just give one small example here. You must have seen sometimes when you are sending a message to someone, or like if you are performing some of the operation, not just be specific to sending a message, if you are performing any of the operation, you must have observed that after a while it is crashing. Like, not always, but sometimes it does, correct? So now, as a developer, how, like, as a user, how you are going to be telling it to the developer that, hey, your code is crashing here? How a developer will get to know where I need to put my more efforts in order to investigate what has went wrong there? By logging in all the messages, like, example, it crashed while sending the message. What if you would have logged all the steps, like, what and all steps we involve to send a message? Unlocking a phone, opening the message app, sending selecting the sender, composing the message, clicking on the send button. Let us say before clicking on the send button it has crashed. So by maintaining these logs, we will see that there is no log for sending message. That means it failed before that. So with the help of these logs, any user will get to understand where it has crashed. So that is where logging comes into the picture, because even if you would have seen your normal code, we provide a lot of logging. Even if we see any code can possibly result into some exception, we are going to be printing one log message there. And that also states which line or which function this must have created the problem. So the whole purpose of creating a logger is that it will help you in understanding where the crash has happened. So now if you will consider this class which I have just taken here, this application which I have just taken here, in this application we will have only one single file which we will be naming as app.log. And what will happen, so whatever is happening in this class c1 or whatever is happening in this class c2, c3, c4, all of that logic will go to one file, and that is app.log. So you will understand how the request flow works. So if you want every class to go and log in the app.log file, you will need an object typically doing that who is typically doing this job for you. Since every class is going to log in the same file itself, what we will be needing, we need one object throughout. Because if there will be multiple objects, there will be multiple instances of that object, and there will be some different logs. You will not be able to understand because every instance is going to be creating a new logging, and then it will be difficult for you to understand how, like, where the flow has broken. So if you will see, in order to maintain one object throughout, that one object is going to be called as singleton. So when you talk about singleton, like I said, it is going to be a part of the creational type pattern. So we are here we are actually going to be dealing with the object creation mechanism. So here what will happen, if you are having multiple classes, let us say class 1, class 2, class 3. So what we will be doing, instead of creating, normally this will create object 1, this will create object 2, this will create object 3. Correct? That is how generally happens. What we are saying, instead of this, all of these should be reporting to singleton object. All right. And that singleton object will go and it will perform the given task. So if we are following this flow, if you will see, what we are doing, we are just trying to make our class singleton here. We are just trying to have one single object throughout. Now we will see how you can go ahead and create a singleton class. So, for this, we have to take care of certain of the things. First of all, you will have to make your constructor private. Like, first I'll tell you what and all things you will be requiring, and after that we are going to be discussing everything one by one. Okay. So, make constructor private. Now, after this, what you will be doing, you are going to see that whatever the object has to get created, that same class will have to create the object. Okay. Or what we can actually say, we are since we want uh, to have a single object, so what we are going to be doing, we are going to have a private attribute of that same class. Because if it is private attribute, so what will happen, only that class is going to be responsible for creating the object. Now since this is a private attribute, and now you will be needing to expose it to the outside world. So in that case, if you ever want to expose anything to the outside world, what you need, some some public thing, right? So in this case, what we will be doing, we are going to be needing a public static method, and that public static method is going to be exposing this private attribute outside the class. Okay. So why we are actually making this constructor private, so by making the constructor private, our class is actually going to be responsible for creating the object. We are not going to let anybody else to create the object since it is private. So only that class is going to be having the access of creating instance of that class, so that That problem is sorted, that nobody else is creating the object for that. So at least one class should be able to construct it. So the class will be creating the object itself. Now when anyone needs that object, then they will be calling this class, and they will say that, can you give me that instance, can you give me the instance of your class? So the static method which every class will use to get the instance. And if you will see here, we are actually needing the three things here first, and all of those things are actually interrelated to each other. The first one is private constructor. So if it is private constructor, nobody else will be able to create a instance of that class. The second one is private attribute. Now that constructor is going to be instantiating that class, and with the help of this private attribute we are going to be instantiating it. The third one is public static method. So this one is going to be responsible for exposing that private member outside. So these are the three things which we are going to be needing outside. Now I will be showing you one example of the singleton class. Now in order to understand singleton design pattern, I have actually taken two examples. We are going to be discussing both of them. Okay. So here, like I said, we are creating one singleton example. And one more thing, here I have written code in C sharp. Oh, sorry, here I have written code in Java. So if you guys want to try it out for different languages, first of all, you see if we have the support for design patterns for that language or not. And if it is there, after that, you just have to modify the changes in your syntax accordingly. All right. So here, what I have done, I have created a singleton class. Like I mentioned, we are actually going to be creating a private constructor for the same. So here, if you will see, generally, how do we create a constructor? Public class name. Here, if you will see, we are creating it like private class name. After that, like just for the understanding purpose, here I'm just printing a message, private constructor. Now, if like I said, what we will be needing, we are going to be needing a private member. So with the help of this private member, we are going to be instantiating our singleton constructor. Okay. So here what we are doing, we are instantiating it by new singleton example. Now if you will see, we have created a public method, and that method is going to be exposing this instance to the outside world. And here I have just created one message, one function which is for printing purpose. Okay. So that's all we have in our singleton exam class. Now from the main method, what we are doing, if we want to create instance, like generally how do we do? Class name, object name is equals to new class name, and that's like that object instance is going to be having that access to that class. But here, since it is private, you cannot do it that way. Even if you will try to do, it is going to give you some error. But how can we improve it? You can just simply do class name, then some instance name, class name. Since this was a static method, so what is the best part about static method? If you want to access it outside, you just want to do it by class name dot method name. So that is how with this instance we are having access to our print message. And here if you will see, the moment we are invoking this, we are also printing this private constructor. How it is actually coming? That is because this is the constructor, and that constructor was holding a message, that private constructor. And with this print message, this hello world is getting printed. So I hope you will have a little clarity across what singleton design pattern is. Okay, let's look into the another example. So here what I have done, I have created one class here. So this is class demo, and this is a public constructor here. Okay, where we are just printing a message, demo constructor. Now this is having another method for printing, which is just printing print demo. Now what I have done in this singleton, like another class I have created the singleton example, and in this one everything is same just like your previous message, except here I have made one change, that whatever message I'm going to be passing, that will get printed here. So I have this method which is print message, and the another one which is print static method. Here message will get printed like message, and here it will be printed like static message. Now when we are going to be creating multiple instances of the demo class, like for that first one, if you will see what output we are going to be getting, multiple times it has printed demo constructor, demo constructor. What does it mean? Even though that file was one, but since we have instantiated it three times, so the three times the constructor got called, and after that we are able to print the message print demo. But if you will see, like here we are creating multiple instances, but if you will see, with the help of singleton, what we are doing, we are restricting the object creation to only one. So with one instance, if you will see, even though we are creating, we are invoking it three times, but the private constructor is only getting printed once. Why? Because we are actually having one invocation for that, because it is a private constructor, and after that we are able to print both of the messages here. Okay, so that's how we are actually going to be implementing the singleton design pattern. Now we will be seeing how we can realize it in different way. Now we will see how you can realize singleton design pattern in different forms. So the first one which we have here is your early loading, and people can also call it as eager loading. First, I am just naming all of these, and after that, we are going to be looking into all of them one by one. Okay. The next one which we have is lazy loading, and this can also be called as on-demand loading. The next one which we have here is your lazy loading thread safe. And the last one which we have is going to be your enum type. So these are the different ways in which you can go ahead and realize your design, a singleton design pattern. So now let's look into these one by one. Okay. Now we will be first of all seeing what is early loading. Early loading, like the name is saying, before starting the loading process, it is getting loaded. That is like before creating the object, like before utilizing the class, we are having the objects which are ready for us. Now what we will first see how this is actually a problem. So there is a problem with the early loading and how it is actually going to be there. So like let us see, we have one person. Okay, now this person is organizing a party. This person has invited one of the friend, and he told that the party is going to start at 8:30. Now certain people are quite early on time. So this friend thought, instead of reaching there at 8:30, why don't I reach there at 8 a.m. in the morning? What will happen if I'll reach early in the morning? I will be there on time. Like this was the simple thought of this person. Now, what is the problem with the early loading here is that if you will see, even though the party was at 8:30 p.m., still the other person reached their house at 8 a.m. And he said that now I will be sitting here throughout the day. I will be interfering with your preparation. I will be eating your food. And if you will realize what is happening in this case, so whatever food the family could have eaten, now this person is also eating the same food. If you will link the same example with the world of programming, you will see that if you are having some early loading, now the variable will get loaded as soon as we are starting our program. So what will happen in that case? It will be eating up the memory and it will be ready for no reason. So what the problem for this problem is to have a lazy loading. So what you can do in our example, you can tell the guard that, in such a case, what you can do, you can have a guard here and you can tell that guard that, hey, the party is going to begin at 8:30. So before that, if any guest is coming, do not allow them to enter. But if the time is 8:30, then you are going to be welcoming everyone. So in the life of programming, this is what we call it as lazy or on-demand initialization. All right. Now I will be just quickly show you this with the help of some example. Yeah, now you can see an example of lazy loading on your screen. If you will observe, The previous one which we were doing, that was nothing but a early loading. Here if you will see what we are doing, we are having a class. After that we are creating constructor for that. Previously what we were doing, at this place itself we were creating instance of the class. But here what we are doing, we are initializing it, because we are saying whenever we will need you, then only we will initialize you. So now in this get instance method, previously what we were doing, we were simply returning the instance from there, right? But in this case, what we are doing, we are first checking, is it null? Because the first time we are going to be calling it, it will be null. So instead of all the times creating the all the time initializing it, what we can do, for the first time when it is null, we are going to initialize and store it in our instance variable. But the second time when we will be calling it out, we will see instance is not null, and in that case we are going to be providing the value, like we are straight away going to be returning it out. The remaining code is same. The only change which we have here is only in this case. So that is how we are going to be implementing the lazy loading. So here if you will see this instance, this is a reference to the object of the class. And if you will see what is this part, that is your private constructor. So that constructor is going to be restricting creating of the objects outside of the class. And if you will see, we have this get instance method. That instance method is going to be returning the reference to only objects of the class. And since this method is static, we can access it using the class name. Now, we are going to be seeing how we can do it in the multi-threaded environment. Now we are going to be looking into how we can utilize Singleton Design Pattern in the multiple threading. So if you talk about Java, sorry, yeah. So if you talk about Java, so you know what a Java is. This is a multi-threaded language. Now, what is the meaning of multiple threads? Like you can actually be having multiple threads for the same, right? By default, if you talk about Java, so it is single threaded. It works in the main thread, but you can make it work even in the multiple threads. So if you talk about the singleton approach, which we have just considered, so that is going to work fine when there is a single thread, because that single thread is going to be creating an instance of that. And this will not work for multiple threads, as in such a case we are going to be having a race condition. Because in this case, although we are having a private constructor, but that private constructor is ensuring that object is not instantiated other than that class itself. But if you are running multiple threads, in that case we can have multiple threads for the same class, and this can get invoked in the multiple threads, correct? First, I'll just show you the code for the same so that you can also understand it. So now we have the code in front of us, where if you will see, we have a singleton class. In that, we are having a private constructor which is straight away printing a message. Then we are having the lazy loading, because if you will see, we are initializing it to null. Then we are having a get instance method which is going to be responsible for instantiating the object. And after that, we are just having a print message. Okay. And now what we are doing, we are having a main method. Okay. We are having a program. Here, what we will do, we are just trying to have different methods. So we are having one method like print first message. The second one is print second message. So in this one, what I am doing, I am creating object of my singleton class, and I am passing a message to print. In the second one also, I am doing the same. I am creating another object. And the third one also I am doing the same. So if you will see, I am trying to instantiate it from three different functions. Now if I want to run it in the multiple threads, what I am going to be doing here, I am using executor service. With the help of executor service, I am trying to execute first, like with the help of execute, we are first calling create first object, then second object, and then we are like calling the third one. If you will be like observing what the message, what the output we are having here, it is printing private constructor, then again private constructor. If you will see, because we are running it in the multiple threads, in that case this one is actually leading to creating two instances of our singleton class. Now if you will see here, the whole purpose of having single object is going to get defeated here. Why? Because we are still able to create instance of that class when we are running it in the multiple threaded environment. So if you will see, like whatever we can actually go ahead and achieve our thread safety in the singleton class. And how we can achieve it? When we are trying to do that, we are going to be creating the singleton class in our Java virtual machine during the execution of the method, which is going to give access to the object. So for the first time in the multi-threaded environment, it is possible, we are having the possibility of a situation that two threads might enter into the get instance method at the same time, which could create two instances of the singleton class, which is not required, which is better word is which is not desirable. Why? Because the whole purpose of singleton class is going to get defeated. So now what we can actually do here, we can try to see how we can go ahead and implement the same. So I will just be showing you how we can achieve. Now we are going to be seeing how you can maintain thread safety in the singleton class. So the first one is you can create instance variable at the time of class loading, that is through early loading. Now, what is the advantage of doing that? That is thread safety without synchronization. So even if it is not synchronized, then also the thread safety is going to get maintained. Plus, what is the another advantage of doing that? That it is easy to implement. Now, we have seen what the advantages we are going to get with this approach. Now, let's discuss what are the disadvantages for the same. So when you are creating early creation of the resources, of course what it will be doing, it is going to be like there could be a possibility that we are not even going to consume it. There could also be situation when if we have created the resources, in that case they will still be lying in the memory, eating up the memory, right? So the client application cannot pass any argument, because here what we are doing, we are just instantiating. But because if you will see here what is happening, just we are doing new object from here. But if we would be doing it with this method here, from that client side, we can also have the flexibility of entering some of the parameters if required, and we can also make it to work in the different forms, so we can achieve the reusability, right? But in this case that reusability cannot be achieved. So if you will see, we have this get instance method. Now what are the advantages of this get instance method? So this get instance method is going to be ensuring the thread safety. In this case, we are actually achieving our lazy loading, and the client application can pass parameters because this is a public method. If we want anything to get passed, we can go ahead and pass it from here, right? So if you will see, this instance is here. What we are we are creating our instance through here. What we are doing, we are creating new object like this, and we are having this get instance method. Now with this, what we will be doing, we are just checking if the applications are synchronized or not. So what we are doing, we are making use of the synchronized block, and that is going to be helpful for ensuring that we are having thread safety, we are having lazy loading, plus we are also ensuring that if the client application wants to pass some parameters, then we are able to ensure it, because this method can go ahead and take the parameters. Also, if you will see here, what we are doing initially, we are just taking that object here, then we are seeing, like to this we are passing the instance, and then we are checking if it is null, then for the first time you are going to initialize it. For the remaining times we are just going to be passing it out. So this is how we are ensuring thread safety here. And if you will see, like, remaining implementation is same. And if you will see here, if we will look at the output, so the private constructor is getting invoked only once. Like the previously, if you have seen, there it was getting printed multiple times, but here it got printed only one time. So if you will notice here, the singleton example which I have taken here, this one. So this one is there to improve the performance of the code. So in cases where the instance is already initialized, which will be happening most of the times, then the volatile field is only accessed because of the statement, right? So here, if you will see what we are doing, we are actually checking that if it is there or not. If it is not there, we are just returning. Otherwise, we can go ahead and initialize it, all right, inside our synchronized block. Okay, so I can just highlight it. So this is how we are ensuring thread safety. Okay, now the next one which we have is the, now let's quickly discuss what do we have in the singleton class of enum type. So here what we are going to be doing, in order to create the instance of that class, we are going to be using the enum block. And from that enum block, we are going to be providing the instance. So that enum block is going to be responsible for that. Now I'll just quickly show you the code for that. So if you will see here what we have created a enum, that is singleton enum and ex, like I have taken example. Okay, so in this what I'm doing, I'm creating the instance like instance. Later on, I am going to be using this singleton enum class, and here if you will see, what am I doing? I'm just creating, like, private member for the message, and here I have set message, and we are also having the print details message where we will go ahead and print the message. And if you will see, like, this is the main method from where we are going to be calling it out. So if you will see what we are doing here, when we want to uh, use that instance, what we are doing, we are using that enum type uh, class dot the type instance type, then we are calling the message. So that is how we are going to be using. So here if you will see, the enum type which we have used here, that is implicitly declared as the public static final field of the singleton enum example type for each of the constant which we have declared in the body of singleton enum, right? So in other words, what we can say, the Java virtual machine is considering that constants instance is of type singleton enum example, and that is also your public static field. So this is the behavior of the class instance which is required by the design of the singleton class. And the Java compiler that takes care of this implicit declaration, and it ensures that this is thread safe. So if you want to achieve thread safety, you can use the enum type for the same. So this behavior of the singleton, this we can achieve even with the help of enum or the thread safety. Now let's quickly discuss what are the real world usages of the singleton, because firstly we have covered what singleton is, then we have discussed what are the different types of singleton. Now let's quickly just see how we can consume it in the real world, and then we will just uh, close this module. Okay, so what are the real cases in like, you can use it. I gave you the initial example of logging. So you can use singleton so that you can go ahead and perform logging, and logging is something which is highly required in most of our projects, because we will surely be needing to log each and everything. Okay, this one can also be used for exception logging, because just now I like, in the beginning itself I said that if it will result into any exception, you should be knowing where it resulted. This also does this is also helpful for connection pool management, because when you are trying to build the connection, you do not want multiple instances of that connection, you just want only one to be there. It is also helpful for the cache management, because again for the cache we just need one instance to be there. This is also helpful for printer spooling. So whenever you require some device managements like printer spooling, because that printer is going to get addressed between access between multiple people, like generally on one floor we will have one or two printers. So how people can do, from their system itself they can give print command, but those commands are going to get addressed one by one. Otherwise what will happen, one page of your request is getting printed, one page of another bit, like another one's request is getting printed, and that is not something which is desirable, right? You can also use it for file management. If there is a file and if you are providing some read write access to that, now what will happen, for the read anybody can come and read it, but if anybody is modifying it, at that time you will only be uh, preferring that only one instance of that file edit is there, so that we are not having rewrites or we are not losing some of the information. So that is how the singleton design pattern can be consumed. So that's all I had for the singleton. Now in the next module we are going to be learning the factory method, factory design pattern, and your abstract. Okay, so I'll see you there. Till then, happy learning. Bye bye.